Hello everybody, this is Iram from Alamkul and today we will be learning about soaps and detergents. And in the last class, we already discussed about these. Your combustion property, addition reaction, substitution reaction. And today, this is the very important topic, soaps and detergents. So we will be learning this. Now, what is basically soap? So here, soaps are sodium or potassium salts of long chain of carboxylic acid and have general formula this. So what do you mean by this carboxylic acid? So basically the carboxylic acid formula is this, which is your R and then C double bond O and OH. And what is this R? This R is your carbon chain, means it's a basically combination of carbon and hydrogen chain. If carbon chain is there, then obviously it's a combi of your both carbon and hydro, right? So the soaps which are sodium Na and which are potassium means K, salts of long chain of carboxylic acid, means the sodium and potassium is a long chain of your carboxylic acid, and they will have this general formula. This is the general formula of your salt. So the long chain of carboxylic acid having a cation of metals like sodium and potassium. Like here we discussed, ki soaps will have the sodium or potassium salts and they will have a long chain of this carboxylic acid. So this is basically the formula of your sodium or potassium, that this is your soap. And here we are having the two metals, the sodium one, or we can also use potassium over here. And this R is basically the long chain of carbon and hydrogen. Okay, so more carbon, and if more carbon chain is there, then more good quality of soap we will have. Okay, just like here, your carbon is how much? 17 carbons and 35 hydrogens, 15 carbon and 31 hydrogen. So if the number of carbon is more, then the quality of your soap is also high. Okay, so this you got, that sodium and potassium of long carbon of long chain of this carboxylic acid, general formula is your this, and this is basically your formula. And here we will attach these two metals, your sodium one and your potassium. Now here we will discuss about detergents. Now what is detergent? So detergents always reacts with hard water. This is the good quality of detergent, that it reacts with a hard water. And detergents, I wrote only D. This is your detergents. These are usually ammonium or sulfate salts of long chain of carboxylic acid. There in the salt, there were what the sodium and potassium, right? Here you have this sodium and this potassium, but here you have ammonium or sulfate. So these are known as soapless soap. Your detergents is also known as soapless soap. And the formula of this detergent is this R, SO3 and Na. SO3 is what? Your sulfonate or sulfur, but SO3 is basically your sulfonate. So here also same we will apply more carbons, then more good quality. So more carbon, here also 15 carbon, 17 carbon, but the formula changed. Here the formula was your C double bond O and O Na. Na because this is for salt one, sorry, for the soap one. And here the formula is this, your SO3. SO3 is for what? This is for your detergent. ठीक है, यहाँ पे लिखा है ना, is usually ammonia or sulfate. So here I am taking the formula of a sulfate. Okay, you can also take a formula of ammonia. And bath from soap, we always bath from soap, not from the detergents. And from the detergents, we usually wash our clothes. Okay, and now we will learn what is the what's the manufacture process of the soap or this detergent. So soaps are made from animal fats or vegetable oils by heating it with sodium hydroxide, एंड दिस प्रोसेस इज नोन एज saponification. ठीक है, सोप्स क्या होता है कि सोप्स जो है वो किससे बनी है? एनिमल फैट्स एज वेल एज योर वेजिटेबल ऑयल. And if you will heat this soap with the help of your sodium hydroxide, then this whole process is known as saponification. So here I wrote this chemical equation. So this is your fat and oil which is also known as ester. So this is reacting with your sodium hydroxide, your alkali sodium hydroxide, and if we will heat these two, we will get a soap and we will get glycerin alcohol. In a simple way, you can say that even ester is getting added with your base, it will form your soap and your alcohol. It means when, wait, let me change the color. When ester is getting added with your base, it will form soap plus alcohol. This is a very easy way of getting this equation. Okay, ester plus base, soap, and alcohol. Now here, this so let me erase this. Here, your ester is this, है ना? CH2OOCO and the C17H35. Okay, so here I am taking this your ester and your this is the formula of sodium hydroxide. And when this is reacting, like when I'm heating these two, I'm getting glycerol and soap. तो ये कैसे मिल रहा है? अब देखो यहाँ पर जैसे कि ये है ट्राई ईस्टर है, ठीक है, मीन्स three ester. So I'm taking three ester over here. So what will happen if I will break this ester from the middle with what? With the help of your sodium hydroxide, what we will form? We will form CH2OH जो है वो क्या हो जाएगा? यहाँ पर CH2 है सब जगह. तो CH2OH will combine and what you will get? You will get C17H35COO Na. Your this or this and plus Na which is your soap. ठीक है, तो अगर इसके साथ ये combine हो रहा है and this is your sodium hydroxide, so we will be getting glycerol. This is your glycerol and your soap. Okay, very basic one. Okay, so here, yeah, like this is your 3ONaC17H35. So bond will break, the negative and the positive will come, so this will become your Na plus and OH minus. So this is a very basic one. And here this is also a soap of the diagram of a soap. We will discuss this also, but let me quickly revise this. What is soap? Soap is like a sodium or potassium salts of long chain of carboxylic acid. This is your carboxylic acid, and R is what? R is a long chain of your carbon. And for soap, we always use your sodium or potassium. Okay, and always remember, if more carbon chain is there, then you will have a good quality of soap. And for detergent, we always use this ammonia and sulfate, and this is also known as your soapless soap. And this is the general formula of your detergent. And here, how we manufacture this? So soaps are getting manufactured from your animal fats or your vegetable oil. Plus, we are mixing this with base, and then after heating, we are getting a soap and also your alcohol. Now we will see this. This is very important. The structure of a soap molecule. Okay, so first we will go with the definition part. A soap molecule, sorry. So your a soap molecule is made up of two parts, a long hydrocarbon part and a short ionic part, which is this group. Okay, तो क्या होता है कि soap molecule is basically made up of a two parts, a long hydrocarbon and also your this short ionic part. The long hydrocarbon part is hydrophobic. Hydrophobic means हमेशा आप लोग सुने होंगे कि हाइड्रोफोबिया इट मींस वाटर से डर लगता है. ओके, सो दैट्स हाइड्रोफोबिक एंड हाइड्रोफिलिक मींस अट्रैक्शन टुवर्ड्स वाटर and therefore insoluble in water but soluble in oil. So hydrophobic is soluble in insoluble in water because क्योंकि उसको तो water से डर लग रहा है, but this is soluble in oil. Now the ionic portion of the soap molecule is hydrophilic, so the soluble in water and insoluble in oil. Now we will see this. This is very important. अब देखो यहाँ पे क्या है कि this is the general formula that we already discussed. If more carbon is there, then more good quality of soap you will have. So this is this, and here is your Na, which is your Na or potassium, which is your soap. ठीक है? This is your soap. Now here, this part. Let me change the color. हाँ. So this part, this zigzag part is what? This zigzag part is your this carbon 17H35. मीन्स ये zigzag वाला पार्ट जो है वो कार्बन का पार्ट है. ओके, दिस O, and here small minus this, oh, sorry, O, and here your small minus is this part, okay, and Na is this, ठीक है, तो यहाँ पे zigzag part is your carbon part, and this O minus is your oxygen minus, and this is your Na plus. Now, this zigzag is your long hydrocarbon chain. Why hydrocarbon chain? Because this is made up of a carbon and hydrogen, and hydrocarbons are oil soluble, means these the zigzag part is hydrophobic or philic. Hydrophobic, okay, why phobic? Because this is oil soluble and insoluble in water, and this short ionic part is water soluble, means this is your phobic part, sorry, this is your philic part, and this is water soluble and insoluble in oil and other substance. Now here, if we will remove this, let's say Na part, okay, and here if I am drawing again this zigzag and then O minus, so basically this part is your polar end, means plus minus, अगर chemistry में कहीं पर भी plus minus होगा, so that basically the word of that plus minus in chemistry is your polar end, and this is which is having no any charge, so this is your non-polar end. Now here, this zigzag part is having no charge. Why? Because the hydrocarbons are always together. The hydrogen and carbon are friends. So they are always together with each other. So they won't have any charge. And if they will not have any charge, then these are known as the non-polar end. And if they will have any kind of plus or minus charge, their oxygen is having minus charge. So then also oxygen will consider as a polar end, not a non-polar. It will consider as a polar. Now here, this is what? This is your alkane, no, no way. Here. So this is your water, है ना? Polar end है, plus charge या minus charge कुछ भी होता है उसको polar end बोलते हैं. And this is your hydrophilic. Hydrophilic. Philic means attraction towards water, and this part, which is your non-polar part, this is your hydrophobic part. See, hydrophobic, this is your water repelling. लेकिन ये किसके टूवर्ड्स, अगर ये वाटर के टूवर्ड्स नहीं जा रहा है तो ये किसके टूवर्ड्स जाएगा? इट विल स्टिक टूवर्ड्स योर ऑयल, योर डर्ट, योर फैट, बट these hydrophobic is insoluble in water, but these are soluble in these substance, and here the your polar end, which is your hydrophilic, so this gets attracted towards your water, okay. It means this zigzag is your zigzag is what? Zigzag is your non-polar end and also your hydrophobic. Phobic है तो obviously water से repel होगा. And this circle part is your polar end, and if this is your polar end, then this is your hydrophilic. Philic means which will get attracted towards water. ठीक है, philic, sorry, philic, ठीक है, तो ये हाइड्रोफिलिक हो गया, वो हाइड्रोफोबिक हो गया. Now this is easy to understand. Now here we can easily remember. See, this is your tail and this is your head. Let's say this is your tail and this is your head, and here is your Na plus. So this is what here also it's wrote. See, your ionic part, and this is long hydrocarbon chain part. See, you have to remember it like this, that hydrogen and carbon are always friends and they will never go against each other. So these are your non-polar ends, means they will not go against each other, so they won't have any charges between them. So these are non-polar ends, and here the oxygen is already having a minus charge. So if oxygen is having any charge, so it's kind of a polar end. Okay, but these are friends, they won't go against each other, so they don't have any charges. Okay, so here, yeah, let's say this is your dirt, okay, and if this is your dirt, and what will happen, this is what, this is your zigzag part and this is your O minus part. Zigzag part, zigzag part, zigzag part, okay. So what will happen if here this is your dirt or any let's say oil, so what will happen, your zigzag part will get attracted toward your oil or dirt, and this O minus part will get repelled from this. Why? Because the O minus will get attracted towards the water, and the zigzag part is getting attracted towards your dirt, because your zigzag part is hydrophobic, and your this last head part is your hydrophilic, so that's why this will get attracted toward your water, and this is your phobic, so this will get attracts toward your dirt. So here this is your dirt, and these you can see over here that all the tail part is getting attracted towards your dirt, not the head part. Why? Just why? The reason is that only that the head is not getting attracted towards your dirt. Why? Because the head is getting attracted towards the water, because head is your hydrophilic. यहाँ पर क्या है? Head जो है वो hydrophilic है. Okay, so just like this, let's say this is your dirt. ये एक dirt है, अब hydrophobic है और hydrophilic है. So what will happen if grease or dirt is anything is over there? Then phobic will get attracted, not the philic one. Philic one will get attracts to water. See, here the water attracting means your this head part is your water attracting part, and this is your oil or dirt which is getting attracted to your tail part. So that's it. This is the your soap structure. I hope you understood. It's very simple. Only you have to remember the zigzag and the oxygen part, which is polar, which is non-polar. Very simple example. The hydrogen and carbon are friends, so they will never go against each other. So that's non. And the upper means, sorry, your head, which is your polar end. Okay, so we are done with this unit. Okay, these two topics already done. This is the last two topics of this chapter. And in the next class, we will start some another unit. Okay, so till then, keep watching. Don't forget to hit the like and subscribe button. Thank you. Bye bye. Take care.